Where we are today, think of as the box of 8 crayons. And you can do a lot of amazing things with that. So the information content for any singular instrument on PACE is way more than we're used to. OCI is going to be the box of 96 or 128 crayons. And so suddenly, the tools you have at your fingertips will fill in all the gaps of color that we could possibly want. This observatory is going to provide global coverage every day. That is another scale of this total volume that is really, really increasing the amount of information we're going to have to work with. We know the atmosphere is changing. We know carbon dioxide levels have increased. We know that it has warmed our atmosphere. Circulation patterns are changing. Places are warmer than they used to be. The deeper dive we take into the relationships between land, ocean, and atmosphere, the more we realize we don't know and we need to learn.
NASA is preparing to take that deeper dive with the Plankton, Aerosol, Cloud, Ocean Ecosystem Mission, or PACE. The PACE mission and its suite of instruments will gather new data on these interconnected Earth systems. The exchange of carbon between the oceans, land, and atmosphere. The impacts of atmospheric particles on marine communities of phytoplankton. The changes these communities are experiencing in a warmer Earth. Reducing the uncertainty of aerosols in scientific climate models. PACE will improve our understanding of these complex connections and how these systems are affected in a changing climate. The color of the oceans can tell us a lot about our changing Earth systems, but there's much more to it than just what the eye can see. And so PACE carries the Ocean Color Instrument, or OCI, to continuously measure the interaction of sunlight with substances in seawater, such as the green photosynthetic pigment chlorophyll A.
We're very good today at saying there's a lot of green, meaning there are a lot of plants. Where we want to go with OCI is what kind of plant is actually there. And so by looking at more color, you can actually start getting the subtleties of this green versus this slightly different shade of green, and then relate that to the composition of what you're looking at.
To measure very subtle differences in shades of any color, OCI needs to measure light at much finer wavelength resolutions than any other NASA sensor. From the sea to sky, PACE's other 2 instruments are multi-angle polarimeters, one hyperspectral and the other hyperangular. Together, they'll take on aerosols, tiny airborne particles, and clouds, both of which change how sunlight interacts with the atmosphere.
So by those 2 polarimeters keeping their eyes on our home planet all of the time, because they're making measurements on global scales, we'll have a much better sense of general evolving air quality on multiple local, regional, and global scales. With very few exceptions, we not only make these data available in rapid, semi-near real time, but we develop tools that are open source that allow anybody who wishes of accessing these data and coming to their own conclusions.
The data from PACE will help scientists reveal complex relationships that connect the atmosphere, ocean, and land in ways that help explain changes we see in our own lives, and in ways that impact generations to come.